This is a 3-mark question on nomenclature and isomerism. 3 different sections, pause on each, try them, and then review your answer. So here's part A, part B, and part C. So for part A, you're drawing the skeletal formula of 3-methyl-butanal. If you've got time and you're not so confident, it's sometimes worth sketching out the actual formula so you can then work out the skeletal from it. Once you do that, it'd be quite straightforward to see what the answer should be, and that's what we have here. When we move on to part B, the displayed formula of C5H11Br, that's the major product of the reaction between 2-methylbutene with HBr. Well, this is the structure of the alkene, and I'm not drawing the mechanism out, but there are 2 different carbocations that could be formed after the H from the HBr has attacked. I could have the carbocation on the left or the carbocation on the right. Now, when we're considering the classification of these, we see that the one on the left is tertiary, the one on the right is secondary, and the major product will be formed by the tertiary rather than the secondary carbocation. It's always via the more stable carbocation. So for that reason, I'm going to put a BR where the plus was, and I've got my formula. Note that it's the display formula. You can't have CH3s here like I'd done in my working out. Every single bond needs to be shown. Finally, thermal cracking of hydrocarbons produces molecules attacked by electrophiles because they have a region of high electron density. So lots of clues here. Electrophilic attack, we do this with alkenes. So we want an alkene with 4 carbons. Now the most obvious example is but-1-ene, but you could have done but-2-ene, you could have done methylpropene, and that would get the mark as well.